Hi guys, and welcome back to my channel. Sorry that I can't be there with you in person today, but here is our lecture notes examples on Chapter 1, Section 2 that involves solving equations and rational equations. Earlier you should have watched PowerPoints or videos for this topic. So now let's dive into working some actual problems. On last Thursday, we talked about graphing equations in two variables using x and y. Today, we're going to work on solving equations that have one variable, where you could have one solution, an infinite number of solutions, or no solutions, depending on if it is conditional, dependent, or if an identity, or if this is an inconsistent equation. So by definition, linear equations in one variable are in the form ax plus b equals c. Solving an equation gives us roots or solutions, x-intercepts, all mean the same thing, that satisfy the equation and become a solution set. Equivalent equations are ones that have the exact same set of solutions. Here are some general guidelines for solving the linear equations. I'm going to pause here for just a moment. We ended class working a two-step problem like the one you see at the right. That was your ticket out last Thursday. Review just a moment and feel free to hit pause if you'd like to write down the steps and the guidelines for solving linear equations. As you can see, we are trying to generate an equivalent equation so we can find the variable value. To do this, you remove the grouping symbols if they exist. You combine like terms, in other words, constants with constants, variables with variables. You add or subtract a constant or a variable on both sides, and then either multiply or divide on both sides. Then, if necessary, you interchange the two sides so that your variable is first. The symmetric property allows us to do that. Now let's get started. I'm going to write that information on my paper over to the side. This is your example 1. You can feel free to follow along with your paper. This is 4x plus 5 equals 29. Looking at my list, it says remove grouping symbols. I have no parentheses, no absolute value, no square root, no grouping symbols, so I'm ready to combine the like terms. Okay, I have a variable term here. That's a linear term. It's an x to the first. And then I have a constant plus 5 and a constant 29. Then the 29 and the 5 are like terms and they should be combined. In order to do that, I would need to move the positive 5 across the equation to the positive 29 side. We use inverse operations for this and it would look as so. In order to move the positive 5 to the other side, I subtract 5 from both sides. Those would cancel. That leaves me with 4x equals 29 minus 5 is 24. Now notice that my equal sign is in the same position. We move constants, we move variables. We do not move the equal sign. It remains in the same position. Now I need the inverse operation for multiplying by 4. The opposite of multiplying by 4 would be division by 4. Those cancel and I get the value x is equal to 24 divided by 4, which is 6. I am not finished until I check my solution and make sure that it's true. So I check it. Is 4 times 6 plus 5 really 29? Well, 4 times 6 I know is 24, and 24 plus 5 is 29. So this has checked, and I know that my solution is correct. Put myself a check mark. Okay, here are examples 2 and 3. Let me give you a moment. You can hit pause while you write these down. Leave yourself some space. Feel free to divide those as you see divided on this page. Tackle example 2 first. Notice that example 2 does not have grouping symbols. It does have a linear term on the left, the negative 2x, and a linear term on the right, the negative 4x. It also has a constant of positive 5 on the left and negative 1 on the right. In order to solve this, we'll need to combine the like terms. In other words, have all the linear terms on one side, have all the constant terms on the other side. It'll look something like this. In order to work the problem, I want to collect the constants with the constants and the linear terms with the linear terms. I always start with the smallest constant. That may not be your pattern. That's what I do. It's how I think. So the smallest linear term is negative 4x. To move it, I would use its inverse operation. The opposite of a minus 4x would be a plus 4x. And if I work this on the right side of the equals, I need to keep it balanced, do exactly the same thing on the left side of the equals. That means that I've moved my linear terms to the left. If my linear terms are going to the left, then I need my constant terms to go the opposite direction to collect those. Then I will move the constants to the right. And you do that by doing the inverse of plus 5. The opposite of plus 5 is minus 5. And minus 5 to keep it balanced. So your linear goes to the left, your constants go to the right, and when you finish, what you have should be every linear term on the left, every constant on the right. Let's see if it worked. So negative 2x plus 4x, that's positive 2x. 5 minus 5, they cancel. Good, I was trying to do that. Equals negative 4x plus 4x, they cancel. Good, I was trying to do that. Negative 1 minus 5 is negative 6. So you'll notice that now I have all of the linear terms, the x terms on the left, and the constant terms are on the right. In order to solve this, I'm still using that inverse operation. 2 is a constant. To get it to go across the equals, you use the opposite operation. Right now it is multiplied times x. To undo the multiplication, you divide both sides by 2. Those cancel and you get x is equal to negative 3. You should check every single problem to see if it really works. So to check it, is negative 2 times negative 3 plus 5 the same thing equal to negative 4 times negative 3 minus 1. A negative times a negative is positive. That's 6 plus 5. This is a negative times a negative. That's positive. 12 minus 1 is 11 equal to 11. Yes, then you know that this is your correct answer. You should always be able to check your work. Example 3 has two different thoughts about how to do it, and what you do really depends on how you think. I'm going to show you a shortcut, and then we'll come back and look at using the distributive property. I think most of us are so used to using the distributive property that we forget to think that 2 is just a constant and 12 is a constant. I could move this 2 to the 12 if I can figure out how to undo 2 times something. Well, to undo the multiplication by 2, I could actually take the shortcut and divide both sides by 2. Those would cancel. And that would leave me with x plus 3 is equal to 12 divided by 2, which is 6. And then I have a one-step linear equation where I have a linear term here. I need to move the constant 3 over with a 6. Undo the plus 3 with a minus 3. They cancel. X is equal to 3. So there's the shortcut method using division. If you used the distributive property, it works the same way. You just have an extra step. So it would be 2 times x plus 3 equals 12. You would multiply 2 times x. You would multiply 2 times 3 and get 12. Then you would need to collect the 6 constant over with the 12, so you would subtract 6 from both sides. Then you have 2x equals 6. Opposite of multiplying both sides by 2 would be to divide. X still equals 3. So you get the same answer either way. If you have a constant outside of parentheses and a constant on the right, you can undo that multiplication quickly by dividing both sides and then working with the result. It's your choice. Take yourself a moment and jot down example 4. Step it up a notch and add some grouping symbols. For example 4, it's still a linear equation. It still just has one variable, and our goal is to collect our linear terms on one side and our constant values on the other so that it will be solvable. This says 4 times the quantity 2x plus 1 minus 29 equals 3 times 2x minus 5. You can pause your video if you need to. Working with that, you'll notice that you have a grouping symbol that needs to be removed so that you'll be able to collect this 29 with this information. We will use the distributive property for this, which has us multiplying 4 times 2, that's 8x. And then 4 times 1, that's positive 4, minus 29 equals, simplify what you have on the left, and then we'll go over to the right. So both of these, that's 4 minus 29, we can collect those on this side to be minus 25. Now we go to the other side of the equals and repeat the process. It's 3 times 2x, that's 6x, and then 3 times negative 5, that's minus 15. No like terms, you bring that down. Notice on this one that you have a linear term on both sides, and you also have a constant term on both sides. You will need to move the linear terms one direction and the constant terms the other direction. I always move the smaller linear term first. The smaller one's 6x, so I'm going to choose to move the linear term to the left. And I'm just going to draw myself an arrow that's where I'm going. You don't have to draw the arrows. They're there for informational purposes. So my constants will go to the left, and then I'm going to take my linear terms go to the left. That means I'm going to take my constants and move them to the right. So to move the minus 25, its inverse will be plus 25 and plus 25. So linear terms to the left, constants to the right, and then let's see what we have. 8x minus 6x would give me 2x. Negative 25 and 25 would cancel. I was trying to do that. 6x minus 6x was cancel. I was trying to do that. Negative 15 plus 25 is 10. Now we have a one-step linear equation you can undo by using the opposite operation of multiplying by 2. Inverse of multiplying by 2 is to divide by 2. These cancel. You get a value that x equals 5. And again, you should substitute this in and check it to make sure that it works. Okay, so some notes about linear equations that involve fractions. You must multiply all terms by the least common denominator. Multiplying by the least common denominator actually makes your fractions disappear. Note, your answer can still be a fraction. Pause your video if you need to write this information down. I call this method of multiplying by the least common denominator to make the fraction disappear, I call it Martin magic. Once you learn how to do it, you can call it your brand of magic. So here is our very first one. Pause your video and write this information down. We will be working through it together. Notice that your denominators here are 4, 14, and 7. I need a least common denominator. And if you don't know what it is from the top of your head, because you don't know all your 14 multiplication tables, I'm going to show you a quick way to find it, and then we'll use this method of removing the fractions by multiplying by the common denominator. This is example 5, and you'll notice that I put that quantity x minus 3 in parentheses, and I also put that quantity x plus 5 in parentheses. These are binomials. Binomials should be grouped. Okay, first things first, common denominator, 4, 14, and 7. We need to know the least common multiple so we know what the common parts would be. The easiest thing to do is just list your multiples and then find the smallest one in the list. So I can count by 4s. 4, 8, 12, 16, 20, 24, 28, and so on. You can count by 14s. 14, 28, 42, and so on. And you'll notice that already we have a 28 in common. And then you count your 7s, 7, 14, 21, and 28. There it is again. So it is 28 that's our common denominator. I'll circle that, and that will be what I'm using here. By the way, it takes 1, 2, 3, 4, 5, 6, 7 4s. It takes 2 14s to make 28, and it takes 4 7s. You can see that in the list. That's 7 4s, 2 14s, and 4 7s to make 28. This is what it looks like. And we will multiply both the top and the bottom, both sides, by 28, and it will be easiest if you make that into a fraction. Just put your 28 over 1. There will be a tendency for you to distribute. Do not distribute, just write your factors down. So here's the process. Step 1 has you multiplying 28 times x minus 3 over 4. Write that information down. 28 times x minus 3 over 1 times 4, which is 4. Purpose in doing that is that your constants, 28 and 4, will reduce. That's because it takes, 4 goes into 28 7 times. You can see that here. It's on the 7th line. So this is really times 7 times x minus 3. Then you can distribute 7x minus 21. Keep your equals in the same place. Don't move it. Repeat that process again. For this one, it's 28 times 5. You write 28 times 5. And on the bottom, 1 times 14 is 14. We're keeping our equals in exactly the same position. It turns out that 28 and 14 will reduce because it takes exactly 2 14s to get 28. Therefore, 14 goes into 28 2 times. This becomes 2 times 5, which we know is 10. Keep your subtraction symbol in the same position. Repeat the process again. Multiply 28 times x plus 5 over 7. So this would be 28. X plus 5 on top. And on bottom, 1 times 7 is 7. Good, because 28 over 7 reduces. 7 goes into 28 4 times, and I can see that in my list because that's on the 4th level. So minus 4 times x plus 5. Distribute. Negative 4 times x is negative 4x, and negative 4 times 5 is negative 20. Okay, it's not quite balanced. This side has 2 terms. This side has 3. I need to condense it down to 2 so that they'll be balanced. I know that it'll start with negative 4x. 10 minus 20 is negative 10. Now we're ready, after all of that work, and this is what I call Martin magic. Notice that your fractions disappeared. Then we can solve that linear equation by grouping your linear terms on one side and your constants on the other. I'm going to move my linear terms to the left, so this one goes to the left. I'm going to move my constant terms to the right, so this one goes to the right. And then see what I have as a result. 7 plus 4 is 11x. Negative and positive 21 cancel. Sorry if you can hear my neighbor in the background. He's running his truck literally up and down the driveway. Negative 10 plus 21 is 11. We can solve that problem. 11 times what is 11? We know that x would be equal to 1. So all that work, and now we know that x is 1. You could substitute that in your original problem to prove that for yourself. It looks like a lot. You take it step by step. Step 1, list all your multiples. Step 2, when you know what's in common, write that outside on both sides of your equation. Step 3, list your factors, 28 and x minus 3, and 1 times 4 is 4. Reduce your constants, and then distribute. And then repeat the process. 28 times the 5 over 14. Reduce 28 over 14, and then multiply, and so on. Okay, so pause your video, write down any of this information that you need to write down, and then we will work through this example 6, dealing with a rational equation that has one or more variables in the denominator. And we also need to show denominator restrictions. Here's a fractional equation, and it's rational because it actually has the variable, instead of being in the numerator, it is in the denominator. The problems are worked out the same way, with one caveat. You have to restrict the domain, or restrict the denominator. If you'll remember, it's illegal to try to divide by 0. We say that division by 0 is undefined. So we look at our denominators. Is there any value that you could substitute for x that would cause 2 times that value to equal 0? Well, the answer is yes. 2x should not be 0. That means that x should not be 0. And it's the same process with this 3x. If x happened to be 0, 3 times 0 would make that fraction undefined. So it looks like this. Let me switch screens for you. The first thing would be to restrict the denominator. We had a 2x should not equal 0, and the other variable is 3x should not equal 0. To solve that, you divide by 2, so x should not equal 0 for both of these things. That is the restriction for the domain. X can be any number in the world when we work it out, but it should not be 0 because a 0 would cause an undefined fraction. Other than that, you go through the exact same process. You look at your denominators 2, 18, and 3. List, and then you list your least common multiple so that you can get a common denominator. Count by 2's, 2, 4, 6, 8, 10, 12, 14, 16, 18. Probably high enough since that's our highest denominator. 18, we already have something in common. That's 18 and 18. 3, 6, 9, 12, 15, 18. 18 is the one that's in common. That is part of our common denominator. So I'll put my 18 here and here. Don't forget that this one also has that additional variable that you need to carry along with it. The variable is x. Put the x on it over here. That is your common denominator. It is 18x, so that you can keep your fractions balanced in numerator and denominator. Put both of those values you're multiplying by over 1, and you're ready to go. Now I have a lot going on the sides here, so I'm going to separate what I'm doing. All that work. This is my denominator. I know that x should not equal 0. This is my common denominator. It took 9 of those 2's, only 1 18, and 6 3's in order to get to that common denominator. Here's the Martin magic process. List your factors. Don't multiply everything out. So I have an 18x, I have a 5, and I have a 2x. We're simplifying as we go per fraction. That's the beauty of Martin magic. As it turns out, there's an x on top and an x on bottom, so they would cancel out. It also turns out that 18 can be divided by 2 evenly, which would give me 9. 9 times 5 makes that whole value become 45. It's not the only way. It's Martin magic, so we're doing it that way. Equals. And then we repeat the process with the 18x over 1 and the 17 over 18. So it'd be 18x over 1 times, well, I just put 1 times 18 is 18, 17. 1 times 18 is 18. If you're looking carefully to see what cancels, it's the 18, which leaves me with only x times 17, and that's 17x. And then we move to the last part. Notice it's a subtraction. Be especially wary with this one. So it's negative, and then it's 18x times 1 over 1 times 3x, which is 3x. A negative times positive, I know that's going to stay negative. Let me highlight that. Those things that are like terms cancel out. The x on the bottom cancels the x on the top. 3 goes into 18 exactly 6 times, so this would be 6 times 1, which is 6, so minus 6. Once you're through the Martin magic portion, then it becomes the linear equation where you group linear terms on one side and constants on the other. This is my linear term. This is a constant. It makes sense to move the constant with its pair on the left. To do that, you use your inverse operation of addition. 51 is equal to 17x. Opposite of multiplying by 17 is dividing. 17 will go into 51 exactly 3 times. And since my answer is not 0, which x could not be 0, I know that 3 is the solution to this problem. Feel free to pause and rewind, and pause and rewind. All this Martin magic in here has you removing the fractions at step 2. Another example that involves a rational equation is rational because it has a variable in the denominator. It might look like this, and rather than having a single constant term in the denominator, notice that it has binomials. These look worse or more difficult than they are. We can take this step by step by step. Go ahead and pause your video and copy the problem down. Just like we've discussed before, when you have more than a single term, these are binomials, you need to put grouping symbols around. I'm going to switch screens for you. You can see that I've written the problem down, demonstrating that I'm using my grouping symbols here for the x minus 2. Now this is looking super complicated. As long as I don't forget to restrict my denominator, I am in good shape. Then I can solve the problem. So step 1 is to determine a value that can make the denominator 0. If I restrict the denominator, what value could 0 out a negative 2? It would be a positive 2. And if you wanted to solve that, and we'll restrict the denominator over here. The only denominator with a variable is x minus 2, so I really only have to do one restriction. I say x minus 2 should not equal 0. And if you can't do that equation in your head, you could just follow equation solving skills. The opposite of subtracting 2 would be adding 2. So x should not be 2, because if it is 2, you'll get an undefined fraction. X over 0 is undefined. So keeping this in mind, we have the restriction in place. We're ready for Martin magic, which is to use a common denominator method. It looks horrible. There are 2 factors. One of the factors is x minus 2, and the other factor is the constant 3. There is nothing different. So your common denominator, and I'm going to list it on the right-hand side this time, because I don't have room over here. Then just put the constant first, is the 3. That's the only constant in the denominator. And the only other factor in the denominator is x minus 2. That over 1. And then that process for Martin magic is the same as it has been. You're going to multiply what's on the outside times every individual term as we go, and we'll start here. So in the numerator of this first fraction, I have an x, and let's put it in parentheses. Over here, I have a 3, and over here, I have an x minus 2. All of this from here and here. This times that first term. And on the bottom, I had x minus 2 times 1. That's just x minus 2. So I multiply all of this times that. And all you're doing is listing the factors that are there. And then notice that the x minus 2's cancel. And the only thing you're left with is a 3 and an x. So all of this and all of this comes down to just 3x. Let's put our equals in because we don't move it. And then list all your factors again. On this one, you have a 2. Now I'm multiplying all this times this. And then you have a 3. And then you have an x minus 2. All this in the numerator of this one. In the denominator, you have x minus 2 times 1. That's x minus 2. Again, these cancel the x minus 2's. And you simplify. You have a 2 and a 3 that remain. 2 times 3 gives you 6. So all of this stuff just becomes the constant 6. And then don't forget that subtraction symbol. And repeat the process one more time. On the numerator, I have a 2 on the inside. On the outside, I have a 3, and on the outside, I have an x minus 2. In the bottom, I have 3 times 1, which is 3. You look to see if anything cancels. In this case, it's the 3's that cancel. So I have a negative 2 times x minus 2. And then you use the distributive property to simplify that. Negative 2 times x is negative 2x, and negative 2 times positive 2 is, times negative 2 is positive 4. We'd want to move our linear term over with the other linear term. Use the inverse operation of adding 2x. That would give me 5x equals, those have canceled, 6 plus 4 is 10. Opposite of multiplying by 5 would be to divide by 5. 10 divided by 5 is 2. Now, this said that x should not equal 2. If I tried to check my problem, I would put 2 minus 2 on this fraction, and it would look like this. 2 over 2 minus 2, that's saying 2 over 0, and that's undefined. When something like this happens, where you have a solution that doesn't actually solve the problem, it's called an extraneous root. It caused your fraction to be undefined. Okay, so there's some examples about how to work through the problems in section 1.2. I hope this has helped. Hope I get a negative result so I can be back with you soon.